An exciting, ever fascinating world of chemistry. We're looking at quantum numbers today. Quantum numbers are defined as means of converting electron configuration into four numbers. Out those long sequences, we can convert them into four numbers. Now, in order to do that, let's look at the orbitals first. This is what S is. We can always put 2 in there, and it's a sphere. P, there's 2 in each, so 2, 4, 6, remember, and they're all together like that. D's are starting to get a little strange. And F's, well, they get really strange. All right, so how do we do this? Well, in order to do this, we make them value N, L, M sub L, and M sub S, where N is energy level, L is the orbital, M sub L is the suborbital, and M sub S is the spin. We'll talk about, when spin, we mean two possibilities, either positive direction and negative direction. And the reason we do this is to overcome electrical repulsion. Okay, so electrons want to fly apart, so if spinning allows them to coexist. Alrighty, so how do we come up with these numbers? Remember, we have S, P, D, and F. Those are my orbitals. I need numbers for those. So whenever we have an S, we're going to make S0 for L. Whenever we have a P, we're going to make P1. Whenever we have a D, we're going to make D2. And whenever we have an F, F is going to be 3. So what about suborbitals? Now, we have to identify how many suborbitals there are. S only has one suborbital. One of those 2 electrons, spinning different ways. So we have one suborbital. We take the negative to the positive of L. Well, negative of 0 is 0. So when we have one suborbital for S, for our M sub L, let's put one line down, one room in, it's 0, looks like that. Now, for P, we have 3. Now, that means we have to have 3 rooms, negative L to positive L, negative 1, 0, and 1. D and F, of course, are 5 and 7, so they look like that. So let's look at a problem. Let's do arsenic. Now, in order to do this, we're going to look at the last electron configuration. Look at your periodic chart. Find arsenic. We see that arsenic's electron configuration is 4p3. So let's do our values, N, L, M sub L, and M sub S. Well, N energy level is 4 right there. P is L, but when we add a number, that's going to be 1. Now, for M sub L, we identify how many suborbitals. Remember how many rooms there are. We said for L, there are 3, from negative 1 to positive 1. We're putting 3 electrons in. So the first electron checks in, second electron checks in, third electron checks in. So we want to know what room this is. That room is right there. M sub L is 1. And it's the first one in the room. It's the positive direction. So it's plus 1/2. And please make sure you put plus. Don't just put down 1/2 because I'll have to take a half point off. All right, copy these down. We'll do these in class. Silver, potassium, americanum. All right. Now, we can also work backwards. How would I do that? Well, let's say I give you N is 5, L is 2, M sub L is negative 2, and M sub S is plus 1/2. Well, since N is 5, that means the energy level is 5. Since L is 2, that means the orbital is D. We put our suborbitals in for D, negative 2 to positive 2. We're checking electrons in. That first electron, only electron, is in negative 2, plus 1/2. It's right there, so that means it's only 1. So it's 5D, and we'll look at the periodic chart. 5D1 is lanthanum. That's my answer. All right, now, copy these down. We'll do the first 2 together in class, and then the second 2 you'll do with your partner. Hopefully that wasn't too bad. Take care. Be good.